well and you can see my screen. Could you just confirm? Is that okay?
Yeah, I hear
you
you.
all know
And
so
see the screen and I also see you, so should work. Yeah.
Okay, super. So thank you so much. My topic here is the resource roadmap for the construction industry sector, and I will draw your attention to a case study that we have done here in Germany. It's our resource roadmap. And I'm not sure, but I would assume that most of you are more than familiar with the cement, concrete, and construction value chain. So it starts in the quarry. We then go to the cement plant where we produce clinker from the limestone out of the quarry. The clinker is the main ingredient in cement, as you know, and then we have, of course, other constituents in cement, which we are calling the main constituents, or sometimes SCM, supplementary cementitious materials. Then cement, of course, is the main ingredient to produce concrete. When you mix cement, sand, and gravel with water, then this hardens within an hour and forms concrete, which of course is the ultimate material for construction. And I think the topic today is to look at the whole value chain and how you might be able to close the value chain once you look at the built environment and ask yourself, how can I close the material loop, in particular against the background of the huge amount of materials that we are using? Because the starting point is and will remain something that you take from quarries. This is a quarry here for limestone for the cement production. But you will see in a minute that it's not only the limestone that we need for the cement. We need a huge amount of raw materials, minerals, to say so, for producing concrete. And this is a topic in our industry. And I'm saying this also against the background that we have another issue, which is, of course, the CO2 emissions coming from the limestone. I mentioned this because decarbonization and resource efficiency goes hand in hand, as you will see in a minute. And this is important because all the measures that you apply in cement making will have an effect on decarbonization and on resource efficiency at the same time. And therefore, these two go hand in hand. And I would just give you a short idea of the challenge with the CO2 emissions, how we reduce them. You may know that the limestone that we are using is, of course, composed of calcium carbonate. And when we heat this up, it forms in the kiln CO2, which is fully emitted. So we have a CO2 emission diagram, as you can see here, which is comprised of 2/3 coming from the raw materials, decomposition of the raw materials, and 1/3 comes from the fuel. And this is the real topic in our sector. The 1/3 from the fuel you might consider to be replaced by biomass, for example, which is happening already, or maybe in the future, like in other sectors, electrification or hydrogen use. Even if this is not mature at all at this stage, the main question is, however, what are we going to do with the 2/3 of the CO2 emissions from the limestone? Now, once we have solved this, of course, we move on and then ask ourselves, what can we do in concrete? And you would see here a typical cubic meter of concrete. And if you add 1 cubic meter of concrete, you can see the weights here, the weight percentages. So it's 80% it's aggregates. We have 13% of cement, and then we have, of course, water and that mixture, which makes the material flow into the formworks when you cast the final building or infrastructure. So the cement is this part here, and the aggregates here, and the difference of the limestone or other aggregates here being used in concrete as compared to the limestone I mentioned before is that this is, of course, natural here. It's not calcined, it's not burnt. Nevertheless, it's a huge amount of material that we use. Typical weight for a cubic meter concrete is 2.3 tons. And you see here that the main part here are the aggregates, which underlines that concrete is from a material point of view, is the mostly used materials on Earth beyond water. But water, of course, is not a material in this sense here. When we look at the decarbonization and the resource efficiency, we look at the full value chain. So we look at clinker, cement, concrete, construction, and recarbonation. I will maybe not talk about recarbonation today here. That is just the take up of CO2 here. But the main beauty of this holistic view is that if you minimize CO2 emissions, you also have a huge benefit for the resource efficiency and vice versa. So as I said, it goes hand in hand. And the main principle is to use the clinker as efficient in cement, to use the cement as efficient in concrete as you can, and the concrete as efficient in construction. Yeah, and these are the levers that go hand in hand, and I will guide you through our approach here, which then also comes up with dedicated number at the end. We have done this first of all for the decarbonization pathways, and some of you may know what we have done here in Düsseldorf together with ECRA, the European Cement Research Academy, and the GCCA, which is the Global Cement and Concrete Association, on a global level. And what you can see here is the timeline from 2020 to 2050 and the total CO2 emissions from cement manufacturing. And what you can see here is that the demand, if we were not doing anything, so to say a business as usual scenario, we have on a global level an increase of CO2 emissions that goes almost up to 4 gigatons per year. And the reason is that we still need more buildings, more infrastructure on a global scale, in particular countries like India, like Africa, for example, Latin America, they still need to make up for these kind of housing infrastructure possibilities at what we have done here, and for example, in Europe many years ago. And then you can see the different levers here. And as I said before, decarbonization goes hand in hand with resource efficiency, because the main lever here in many countries is to use concrete in design and construction as efficient as possible. We have lifetime extension here. We have the recycling of concrete parts to just not need to produce new concretes in order to build. Then we have the efficiency in concrete production. We have the savings in cement and binders. I will not go to the very details here, but I will pinpoint a little bit on the main levers that we have here. And of course, the savings in clinker production. And from a CO2 point of view, and Mr. Kitzweger will talk about this later, there will at a given time be a remaining part of CO2 emissions, which are basically unavoidable. All the levers that we have pulled before are levers which we are going to pull to the very extent possible, and maybe even beyond of what we see is possible today. But there still will be remaining emissions, and these need to be captured, and the CO2 needs to be utilized again if that's possible, or needs to be stored. Now, this is what we have done here in our country then, like in other countries as well, where we were of help. So we ask ourselves, is it possible to build up a value chain which is climate neutral? What are the challenges we are facing? What are the technologies and what the innovations that we need in order to make this transition happen? And what is the framework? What are the external prerequisites that we need for this? Now, again, let me come back to the holistic view, to use the clinker as efficient as possible in cement, to use the cement as efficient as possible in concrete, and to use the concrete as efficient in construction. This is the main reasoning of all the roadmaps which lead to a decarbonized CO2 value chain and a resource efficient value chain. When we go to the CO2, you see here that we start in our country with 20 million tons annually today. And what you see here, the levers, the construction demand will slightly diminish more or less here. Then we have savings that we can take at the clinker plant, which is also biomass and alternative fuels. But the main points here I would like to draw your attention to in a minute is how can we use recycled materials as main constituent in cement. And there you immediately see that there's a strong link between resource efficiency and CO2 abatement. Then we have some possibilities in concrete and in constructions. These are numbers, of course, here which you see in other parts of the world going to be much bigger. This is against the background that some of the levers have been pulled here in Europe, and the countries which are also represented in this call here have been pulled, and the potentials have been lifted some time ago already. So let me just draw your attention here to the clinker and cement, not focusing on the topic like CCUS, for example. Now the clinker, and let me go back here. The clinker and cement, as I said before, its the main purpose is to reduce the clinker as efficient in cement as possible. And you can see here the relationship between the two, and we call this the clinker factor. So on a global level, we have a clinker factor here that started with 80% in Europe, in Germany, I'm sorry, with 85, 86% in 1995. And you can see here that it's decreasing significantly in a very positive way. So we are around about at 70% here, and we are aiming to less than 60%, between 50 and 60% on a national level in our country, but also on a global level. And this reduces not only CO2, but it reduces also resources that we use for clinker burning. But then the question is, where are the resources coming from if you replace the clinker by something else? And this is, of course, where we try to make possible use of resources to a bigger extent as compared as we did it in the past. Now, you ask yourself, what kind of substitutes can we have for clinker? Because the amount of cement is basically given, yeah. And if we reduce the clinker in cement, the question is, what are the other materials? And I would like to draw your attention to materials which are suitable for replacing clinker. Suitable means they either must contribute to strength development or the physical properties of concrete. So you cannot use any material. It's not that you purely dilute the clinker. You must have some benefit in the materials that you use. And there are calcined clays, for example, which have a high potential. And then we have natural puzzolanas. These materials have some activity by itself, and they can help to substitute the clinker. I will not go through all these here, but this is the slide that shows you that we have a potential here to really substitute clinker and reduce CO2 emissions. Now, these materials, of course, from a resource point of view, are natural materials like the puzzolans or the clays, while, for example, the recycled concrete fines are not natural. They are natural in the sense that they have been, of course, natural at a given time, but then they are part of concrete, and there's a huge potential here to recycle concrete fines in cement. This is not the fact that we recycle concrete as an aggregate in concrete itself. It's just to get the fines back into cement. And this is a typical concrete. How should I say? Once it's broken, yeah, you can see here the white part. It's basically the outer part is the hardened cement paste. So this is what used to be cement powder at a given time, but with water that has hardened and has glued together the aggregates. You see here the more darker part. This is more the aggregate part, and this comes when you break concrete. And this, of course, is looking like a typical aggregate, so that can and replaces already today sand and gravel in modern concretes. If you have concrete building, if you have a concrete road, for example, that can be 100% recycled with respect to concrete, concrete ingredients. The biggest challenge, however, are the fines. The fines, the sandy part of this, this is when you look at this, is already clean. So it has been sieved, it has been classified, but the sands cannot easily be reused in concrete for technical reasons. But the concrete fines, the fines can be reused in cement, and you will see this here. Once you take this material, you break it further and you classify it. You can use this as a cement constituent, which of course is very, very good. And by the way, this material here, if you let it sit there being exposed to ambient air or enriched CO2, this material even can take up CO2. This is what I mentioned before as recarbonation, which is very, very good with respect to not only use the material as such, but also reabsorb CO2 and then contribute to lowering the CO2 emissions. And I will not bore you with too many slides from our cement standard, but this is a cement standard, and it has in part here with the reconcrete fines here. And you can see that the different cements have the possibility to be composed of clinker here, and then recycled concrete fines, and even other materials which are well tried and traditional. So we have the possibility here with the recycled concrete fines to reuse material in the sense of closing the recycling loop, but at the same time, the huge benefit is that we also contribute to CO2 savings. First, because we use less clinker in cement. Second, because the concrete fines here can absorb CO2 and allow us then to have a positive impact on the full value chain of cement and concrete. Now, if we go back to the waterfall diagram here, I talked about clinker and cement, but let's have a short look at the construction side here. The question is what can happen on the construction side? Any amount of concrete that we save will save cement and will save clinker and has a contribution to lowering our CO2 emissions. If you look what is possible today, you can see that for example, if you have a ceiling here and you have it as a massive reinforced concrete ceiling, or if you have a concrete hollow slab here ceiling, you can see that the material is less, so it's less resources. At the same time, it's also less CO2, and you see the global warming potential here per square meter on the right side, just to give you an idea. So you use cement and concrete more efficiently, but of course, and this is the possibility for us as an industry to create value here. The specification of the cement and the performance of cement, of course, must be kept at a very, very high level, and the cements of the future will have to be produced in a slightly different way than today. So the particle size distribution when you grind the cement is a dedicated one. The quality control must be high level in order to make sure that these materials, of course, qualify for what they are needed for. And how that really works is to be seen here in the Architectural Concrete Award that we issue here every second year in Germany. And you can see here the winners from 2023. So you see a full quarter here where you mix existing and new houses. Just take advantage of existing infrastructures. You see a park deck here, which typically in the past used to be a massive uniform block, but you can see here that concrete here is only used where you need it for maintain the forces, yeah. And this, of course, saves material. It's a very intelligent way to produce concrete here, and it has been awarded. The same is the reuse of concrete elements here in a school here in our country, and also here other elements to be reduced, even if they are tiles. You can see that concrete, of course, plays a major role. So that is what is possible. The point is that the question is how much you can reuse, recycle. Here is an open one that depends on the building traditions in the different regions. It also depends on the building as such, but there's a huge potential, and I think we will lift this potential in the time to come even further. And against this background, we have then added another resource, another roadmap here to our roadmap for CO2. We have added a resource roadmap here, in which we not only looked at the CO2 along the value chain, but also to the respective resources that we need in order to satisfy the needs of a full value chain. And the question that we had is, can natural resources and raw materials being saved and replaced along the value chain? What are the technologies and what are the innovations that we need? And what are the frameworks, the prerequisites that we need in order to build up a resource efficient and resource saving concrete construction? And also, and that was the main purpose here, to show what are still the challenges that remain, even if we recycle quite a bit we will never be able to come to a fully closed loop in which we don't need any new primary raw materials, as you see in a minute. So this is the situation for our country, and I'm sure that the situation will be similar looking in other countries as well. So you can see here that we are using as a country in Germany 1.2 billion tons of raw material each year. And you see that 20% of this goes for concrete and cement. And then, of course, we have other raw materials. Of course, the fossil energy sources we should not forget. We have biomass here, but of course, we have also minerals that we use for other purposes, not only for cement and for concrete. Now, this here, this gray part, then of course, is then the starting point for cement and concrete raw materials. And what you can see here is that we have roughly 240 million tons of raw materials to be used in our country each year. And there are others, of course, other materials that we use here, but the main part here is gravel, quartz, sand, natural stone, and limestone to be used as a raw material for clinker or to be used as an aggregate in concrete production. And I will not bore you with too many details here that can be read in detail in the resource roadmap that we have issued, but you can see here the pathways from clinker to cement and to concrete and how this all fits into each other. Yeah, so the limestone that we need for the clinker production, and then of course the clinker that we use in cement. We use alternative materials, as I mentioned before. The upcoming recycled concrete fines are a major part here as well. And then, of course, we have a huge amount of aggregates that we need for concrete at the end. We have looked at the different possibilities. What can we do? Can we reuse structural elements here when concrete buildings are taken apart? Can we reuse components? This is rather limited because the buildings of today have not been designed in a way that structural elements can be used to a high degree. This is, of course, something that has to be developed in the time to come, and will also require, of course, dedicated concrete for these elements. Then the recycling of aggregate is common practice today. If you have pure concrete, for example, it's completely recycled back into concrete. If the concrete is diluted in what we call construction and demolition material, then the recyclability is still 100%. Not all the fractions then go to the concrete itself, but they are used as other materials in the concrete in the built environment and its value chain. And then, of course, the crushed sand here, as I said before, goes back to cement. If you recarbonate it, it saves CO2 and it saves clinker in cement. Or you can just use it back in clinker because it has calcium and silica and it's already decarbonated. So again, if you close the loop here with the crushed sand, you can contribute to resource efficiency or to CO2 abatement. And this is a waterfall diagram, but this is not the same as you have seen before for CO2. This is the one for the material, and you can see here, it's the materials that we are using in our construction value chain here in Germany for cement and for concrete. And you can see here in clinker and cement. Clinker is the most, of course, for limestone to be used as starting materials for burning clinker. And we have the small part here, other materials that we use in cement as a clinker substitute. And then the big part, of course, here, the big part here are aggregates for concrete production. And I think there's something that we cannot really influence, which is the building demand. To be honest, in our country, we have still a lack of infrastructure and buildings, and this will have to change. And I think the numbers will be different in the time to come. In concrete, you certainly have the biggest possibility to save resources, and this is just to better close the loop with respect to construction and demolition materials. And this goes with new recycling and separation and pre-treatment processes. It's very interesting to see that many cement and many concrete producers invest now in recycling companies to make sure that they integrate this business into their value chain. The new quarries of the future are also and you know the term, the cities, the urban mining areas where we can take advantage of existing materials. But the main message here is, and this is something that is somehow not well understood, we still need primary raw materials in the time to come. The reason is that we haven't built environment, and it's there. You can see it as a reservoir, you could see it as an urban quarry, but it's there. You cannot just take it as a natural resource as it is. So that is still the built environment is to some degree is not being able to be used as a resource because it exists. It simply exists. Now, this is the main message, and this is something which is even for regional policymakers is a difficult message. We will not be able to fully replace our resources by only recycling materials. This is part of the truth as well. We need access to primary materials also in the time to come. Now, the alternative resources for clinker production, let me just go back to the recycled concrete sands here. I think I have mentioned this before. If we recycle the crushed concrete sand back to concrete, we can recycle. We can save resources. But as I said before, CO2 can be taken up, and it can take up to 20% as a global average, 20% of the original CO2 emissions. And this something is, of course, that we take advantage of. And to tell you, the cement industry is also investing in recycling of concrete because it's a huge potential to drive up the recarbonation rate of concrete, because it's a fine material. You can easily expose it to the ambient air, or you can even expose it to an enriched environment of enriched CO2. And this is then, if you want, so it's CCS, and it's different from that. Means you capture the CO2 by the recycled aggregates, and this is then, of course, being reused in cement making, just as a carbonated mineral. And this is a real good contribution and saves CO2 and primary resources. Now, there's always the question of can we extend the lifetime of a building? We have approximately 5% estimate here saving due to longer use and reuse of concrete construction and elements. This, of course, is something that will develop over the years. The question is how can design and construction being updated with respect to longer use and reuse? The point is that has to do with more prefabrication, for example, more concrete elements. And this, of course, will also then be demanding for the cement industry. The cement industry will adapt to these new types of new ways of construction, with a sense replying to this with dedicated cement. So the cement of the futures will be highly sophisticated, will be top quality cements being composed of different materials with a low clinker factor. So there's a great future for the cement industry to contribute to concrete or to concrete buildings, which might have a longer use and reuse, or to say so, a longer lifetime. This was a message I made before. There's no way around that we still need primary raw materials in the time to come. I think that's also what was clear from the study that we did in our country. And I think the same situation will be in many other parts of the world. Now, the final slide here is what are the prerequisites that we need for this? We need a sustainable material flow management. That sounds very easy, but you know, the logistics and also the legal framework is sometimes the biggest challenge when you try to recycle materials. If you take a building back into the circle, in the value circle, then we need maybe green lead markets for resource savings, cement and concrete. It's the same as for low carbon cements. There are no lead markets for this at this time, and these have to be developed. And I think it's also on us that we need to communicate nicely about what we are doing here. And of course, as I said before, the cements will be highly sophisticated in the time to come. So we need qualification at our side, but also qualification along the value chain. So construction is getting, for sure, more sophisticated because it's really dedicated to resource efficiency and to CO2 decarbonization requirements. Finally, and I think I mentioned this before, enough is we need to have secured access to primary raw materials, even in the time to come. And this is in some parts of the world, and I can tell you the situation in our country is always a struggle because you have always this conflict with nature conservation on one hand side and then access to raw materials for our sector. But having said this, I think I made clear that we have a coincidence, that we have a going hand in hand decarbonization and also resource efficiency. There are many levers that we can pull. It's a huge opportunity for us in our industry. It's a huge opportunity for the whole value chain. I think we have to work together here along the value chain, and we will be able, I'm 100% sure, to come up with decarbonized materials in the time to come, which are based on resource efficiency in the broader sense, including, first of all, of course, the recycling of material at its final stage. So having said this, I would like to thank you very much for your attention and, of course, for listening so nicely. If there are questions, I will be around, in particular at the panel at the very end. Thank you so much.
Yeah. Thank you, Martin, for this excellent presentation. Thank you very much.